So we took a look at our bone, and unfortunately it was too big to scan all at once. So we broke it down to 4 different scans, and you could see we scanned the different parts on the bottom of the screen there. So we started off by using the align feature to stitch 2 parts together. And you can see on the left and right, we're starting with the first 2 parts. And it prompts us to use 3 markers on the top. We try to match those markers on distinct features on the left and on the right part. And that would help us, help the software kind of recognize where to kind of stitch it together. So we just changed the view here. It makes it a little bit clearer to see the features. And you can see on the right part there, there's some holes, and that's where we put our electrical tape markers on the physical bone. That we did that so it could help us in this process to kind of find the distinct features and how they align. So we place all 3 markers on the left and on the right part, and we click align feature on the top, and there you have it. It's all one piece. So now that we have 2 pieces stitched together, we did the same for the other 2 pieces. Same process, 3 markers on each, and then hit the align feature. We'll show you the final product here. So there you have it. So the next step is to use the fuse feature on the top to convert this body from a hollow body to a solid body. So it's very straightforward. Click on fuse on the top. We go into the settings, and we have to just make sure in the settings we set it to volume merge and put it at a reasonable pixel number. We set ours to 10 pixels and hit apply. And next we just run the fuse. So the next step, we go to polish, then simplify, and hit simplify. And as you could see, there's a tolerance bar on the top. We set ours to 0.2, and the higher the tolerance, the less resolution we have for our mesh. This helps us when we export it to SolidWorks later, so it's a smaller file. And you could check the size of the mesh by going to File, Model Information, and check how many triangles. And our initial one was 149,000, and we were able to bring it down to 32,000 triangles, and that will help us with the size of the export file. And finally, we save our model as xyz.xyz. There is multiple formats for SolidWorks to recognize, but we decided to go with .xyz. So next we go to SolidWorks, open a new parts file, and before we are able to import the .xyz file, we have to make sure we have the Scan through 3D add-on. So we go to Tools, Add-ins, and make sure we check on the scan, make sure we have the Scan to 3D checked. Next we go to the toolbar, right click, and make sure we have the features highlighted. So we go to open and find our .xyz file and make sure we select the point cloud and now recognize our format, select the file. So now that we have our point cloud data, we find the point cloud data on the left-hand side and run the mesh prep wizard that we could find in the features tab on the top, where unfortunately it's not showing in this video, but you'll find it in the Scan to 3D tab, and run the prep mesh wizard. It'll go through the setups, give it a name, go next, and you could run down, and we just use the default for ours, and it'll automatically generate the mesh according to the points we have right now. So now that we have our mesh, we could choose to make it more smooth by changing the bar, and we put ours to the maximum, so you can see the edges are a little bit more smooth now. We go next. It recognizes the holes that are in the body, and there's quite a bit, as you can see. So in this feature, it'll fill up the holes automatically. So we click next. And once that's filled up, there's still holes, but we could do those and fix those manually. We could also do them automatically using the launch surface wizard. So we set ours automatically, so it'll try to fix as many holes as possible automatically. We choose the default surface details, so we keep our models as small, or our mesh as small as possible. Over here, the error shows us that there is still holes in our model, and we decided to just go ahead and delete those and fix them manually. So this is what we have as far as our model. As you can see, there's still holes that we decided to delete. And in order to do anything with this model, we have to make sure it's a solid model. And before we could do a solid model, we have to make sure we closed all these holes. And we'll use the surface features to be able to fill these holes. And in order to do that, we select it from the left hand side. Make sure we have the surface features, and this is all the types of surface features that we will use. Mostly we'll use the fill feature and the knit surface. So starting off, our first fill feature, we have a hole in the middle of this body. We'll show you what we've done. This is on the other side of the bone, so we selected the boundaries around the hole, as you can see, and clicked surface fill, and automatically was able to fill in that hole. So the next step was to cut off the bottom of the bone, and to do that we decided to put in a plane, and we could insert a plane by going to Tools, Reference Geometry, Plane. So as you can see, it's on the bottom there. And the reason we cut this off is because there's quite a bit of holes, and it's going to take a lot of time to fix these holes, and at the same time we do not need this part because the prosthesis is going to go where this part is. So decided to put out a reference plane, and next use the surface trim feature to trim that whole section out. So as you can see, if we go into the surface trim, it just allows you to choose the bodies that you want to cut. So we give it a reference body, which is our full model, and the section that we want to cut off, which is on the left-hand side of the plane. And then we just click OK. And there we go. We have still a hollow body, but at least all the holes in that one we don't have to worry about for now. So next we would want to fill out that hole by using the surface fill feature. So same as we used before, we select the boundaries around the holes, on the surfaces around the hole. So we select the boundary one by one, as you can see. Click OK, and it automatically fills it out. We're not worried about the shape of it. We'll modify that later. We'll just look at and filling the rest of the holes. So next we have a hole on the top of the model. We use the surface fill again. Same process, select the boundaries of the surfaces around the holes. Click OK. So the next step is to use the knit feature, which stitches our body and makes sure it's watertight. So in order to do that, we have to make sure there's no hidden holes, and there's a great features we could use to do that. We go to Tools, Evaluate, and Check. So this check feature shows you all the hidden holes just by clicking check, and in our case we had 3 hidden holes. It's great, it shows you exactly where the holes are, so you could go back and use the surface fill feature to fix those holes, and once we make sure there's no hidden holes, we could proceed and do the net features without any errors. So next, now we could use the surface net feature. It's pretty straightforward. We just select our entire body, as you can see, and we have to make sure that we select the create solid that's on the bottom there. And if that's grayed out, it means there's a hidden hole and you have to go back and use the check feature to find those holes and fix them. But in this case, everything checks out. We were able to click OK, and now it's watertight and it's a solid body, and we could go ahead and modify it further